Okay, so today what we'll do is we will look into more into the smart contracting platforms, especially the platforms which you can use to develop smart contracts, right? So Ethereum, we have several platforms, and again, some are still evolving, yeah, and things like that. But we will focus on some of the important platforms. And again, we will not be get done with all the platforms today. But today, what I will do is I will focus on the main architectural components of the Ethereum and also look into how it works and some kind of basics. And next week, we will briefly touch upon the Hyperledger Fabric and also Corda and other platform, again, from the very high level architecture perspective. So let's focus more on when we look into the smart contract development platforms. So basically, as we also discussed previously, like the you develop the smart contracts and deploy it on a blockchain. So, and again, the underlying blockchain has several components that will guarantee the immutability and other kinds of things. And so based on the type of the contracting languages and type of the underlying blockchain, you might have different types of applications. For example, Ethereum is mainly meant for the transaction oriented, or you can say the currency oriented transactions, or for transferring money between different the accounts and other kinds of things. And whereas the other platforms, for example, Hyperledger Fabric, which is used for more permission blockchains, like where you have several companies collaborating together, and then they can have a blockchain for business processes and transactions between them. So it depends upon the type of use case you are building, and there are several platforms that exist. Again, Corda and Stellar, these are mainly with the different purposes and different architectures and things like that. Mainly in this course, we will focus on Ethereum because it is quite popular one for smart contracts, and nowadays I think the majority of the smart contracts are being developed on Ethereum. It has the major share as a platform. Of course, you can also look into Hyperledger Fabric, which we used in our project a couple of years back. But getting Hyperledger Fabric and making it configured correctly and running it perfectly is really, really a big challenge. So that's why that's why it is we will focus more on the more on the Ethereum platform. Just 1 second, I have some issues here. Okay, so let's get started. I might be yeah. So let's focus on Ethereum today, and then next week we'll touch briefly upon the other platforms. So Ethereum, as popularly known, so Vitalik Buterin, he's a Russian Canadian programmer. So, and he was you can say, he founded Ethereum when he was 19 years old, when he was studying in the University of Waterloo, I think, yeah, and around 19 years, he published the first white paper on the Ethereum. Of course, he was a big fan of Bitcoin, you can say, and he has been working with cryptocurrencies since age of 17 and things like that. But and then he was also quite active in the Bitcoin forums, especially. And then he proposed this the white paper proposing the architecture of the Ethereum. And then he got a funding. I think some venture capital fund funded him, and then he dropped out of the University of Waterloo in Canada, and then he worked on the full time on the Ethereum application. And finally, Ethereum was released initially in 2015, and then official release was in 2016, around 2016, like that. And yeah, officially it was launched in 2016. as a decentralized platform for spot contracts, especially focusing more on the contractual running, executing the automated contracts, and initially as the proof of work as a consensus algorithm. So in the beginning years, before recently, where the Ethereum has moved to the proof of stake. Before that, it was also consuming a lot of energy like the Bitcoin. So Bitcoin uses the proof of work, as we discussed previously in the previous course as well. And also Ethereum was on the proof of work till 2022 September. Right, so this is the evolution of you can say the timeline of Ethereum. So initially it was released in 2015, but the official release is around 2016. And remember, we were discussing about the DAO hack, when we are discussing about the decentralized autonomous organizations. We also discussed that the DDAO, which was the crowdfunding platform created on the Ethereum, and then there was we have discussed that there was some flaw, or you can say bug in the Ethereum code, which allowed some hacker to drain out 80 million US dollars or something like that, right? So then they were then they created a hard fork to restore the Ethereum and things like that. And you can see these forks are nothing but the updates to the protocol and things like that, right? So whenever you have an update to a protocol, normally what you do is you will, based on the import of the protocol, either you can go for a soft fork, or you can go for a hard fork. Hard fork is like imposing that, okay, if you don't run this version of the software, then you are not allowed to participate in the mining, and so that is called a hard fork. But on the other hand, what is soft fork? Soft fork is nothing but you are advised to adopt this version of the software. But on the other hand, if you're running the old version, you're also allowed to do some minimal work, but maybe not full-fledged functionality of the protocol, but you are allowed to do something. So based on the updates, you will have the soft and hard fork and things like that. But one of the biggest challenge for Ethereum was the power consumption, right? So it consumes a huge amount of energy, and there was a lot of big hues and cry for many people, saying that the Bitcoin and also the blockchain, Ethereum blockchain, they have been consuming a lot of energy, and which is quite unsustainable. It is true, because we have seen that most of the energy is spent just to find a hash value, solving a hash puzzle, and so it is nothing but the waste of energy, right? So then Ethereum was actually they initially they realized the limitation. Even the proof of work offers some kind of what you can say, some kind of guarantee or protection against the attacks. But you can see that Ethereum was attacked in the beginning years, right? So of course, due to bug in the software and things like that. But they realized that this is not going to be sustainable in the long run. And if we are going to continue with the proof of work, probably we might not able to attract a lot of smart contracts and things like that. So then they started a project called Beacon Chain. So in around approximately 2020, with a plan to migrate to proof of stake. Even though if they want to migrate to proof of stake, they cannot do it just by one flip or in one day, right? Because you have to develop the protocol, and you have to develop the protocol in such a way that it doesn't conflict with existing transactions. And also, you need to somehow carry over the Ethereum state. So for example, you can see here, before the merger, you can see here is the merger, right? Before the merger, you still have the Ethereum and Genesis block and transactions and all other things. We still want to carry that state forward, but on the other hand, they want to move to a proof of stake consensus protocol. So that was it was started with a good purpose of moving to proof of stake, and so finally the merger happened in September 22nd. Yeah, so September 2022, and then the energy consumption, because of moving from proof of work to proof of stake, the energy consumption has been reduced by almost 99.95%. So it was a really, really good move for Ethereum to move to the proof of stake. And then, so what did it do is, so at this point of time, the merger happened, right? They try to keep the whole Ethereum state. So that means the transaction, blocks, and all other things which happened previously before the merger, they were intact. They were not touched, right? So that's why Ethereum 1, which is called the execution layer, and which handles the transactions and the execution and things like that. What they did is they moved this Ethereum 2, which is like the you can say layer on top of the existing one, which takes care of the consensus layer, right? So it now it will validate all the new transactions and blocks and other kinds of things according to the revised consensus, so, which is called the Ethereum 2. So that's how the merger happened. Any questions or comments? Okay, so if you look into the Ethereum blockchain, basically it contains 3 elements. So the first one is the transaction list, like as you see from the Bitcoin block, similar to the Bitcoin, the block in the Bitcoin. So it contains a list of transactions which are validated by the miners and put into the block and things like that. And it has a block header containing 15 elements and things like that. And another interesting important thing is it also has the provision for Omer nodes, or you can say Omer blocks. So Omer blocks is nothing but the list of all the uncle blocks which are included in the network. So let's see what is a Omer block. So let's say that this is a valid Ethereum block, right? If the block is valid and it is validated by the miners, and if it is accepted by the miners, right? And then it will be added to the network as a regular block. But on the other hand, if let us say that if the block is valid, but on the other hand, it is not accepted by the other miners because they have already accepted another block or something like that, and then it will become a uncle block, you can say, or Omer block. So let me elaborate further. So the reason why it is happening is, remember, in case of Bitcoin, we have a limit of transaction for limit of creating a new block is for every 10 minutes, right? So that is the maximum time you can create a block and get it accepted by all the miners and things like that. So the block creation time in Bitcoin is a bit more, 10 minutes. When you look into the Ethereum, and the purpose of Ethereum is to run the transactions and moreover focused on the smart contracting transactions and things like that, they wanted to have a very fast block generation phase. So for example, the normal block creation period is 15 seconds per a block. So that means in each 15 seconds, you have a new block put into the network, and then there will be several blocks competing in parallel at the same time, created by different miners. So there is a chance for there is a chance that your block is not ended up in the longest chain, right? So that's why you have these the uncle blocks or Omer blocks which are happening. So that means this is nothing but a block which contains which is valid, but it competed to be a block added to the chain, but it was not successful. So then what you can do is rather than wasting all the energy spent, and these blocks, they don't get the same remuneration as the normal block, but on the other hand, they get some kind of remuneration. So, but what you can do is you can only include this the Omer block if it is within the last previous 6 blocks back. So that means, let us say that you completed your block and you got lost it, and then maybe in the you have a chance to add this as a Omer block in the next 5 blocks generation or something like that, right? So it has to be done a bit fast and things like that. Again, the main idea is to to decrease the centralization and also the reward the work. So that means the miners have done the work, but unfortunately the block didn't made it to the longest chain, right? So that with that purposes to provide some minimum remuneration to the miners who didn't make it to the longest chain. So that is the main idea of the Omer blocks. I think they get each Ethereum block will get 5 ethers or something like that, and then they get a very small amount of as a remuneration. So this, if you look into the Ethereum block, it looks like this. Basically, it contains some headers and then the list of transactions and some other information like gas used, gas limit. This is the maximum limit you can specify, and some extra information, right? So we will get into these details more when we come to the programming part and stuff like that. So again, like Bitcoin, all the blocks are visible. So that means they are accessible, and but blocks have a different structure. Even in the internal transaction ordering structure is also different than the Bitcoin. In case of Bitcoin, we use Merkle trees to hash the transactions and create a transaction graph. But here we use a different structure, which is built on the Merkle tree, but a more advanced cryptographic structure to put the transactions into. So yeah, blocks are generated at a fast pace. So here is the reward, right? So and normally blocks are generated for every 12 to 15 seconds. So that means they are generated at a very fast pace, right? So it's unlike the Bitcoin, which gives 10 minutes. So here you have a very fast generation time. So that's why you have a chance to get a lot of uncle blocks or Omer blocks, which didn't make it to the longest chain. If a block made it to the longest chain, the main reward is 5 ethers. So that is the block reward, which the miners can get. But the miners who they can also get by including uncle blocks. So that is which is almost like a 1/32 of a ether. So that means it's a very small fraction, you can say, 0.03 ether or something like that. So and then they can also add these uncle blocks up to a maximum of 2 or something like that. So that's why. So they get a small reward for adding to the uncle block to chain. And yeah, so some of the key differences, if you look from the Ethereum versus the Bitcoin. So one important thing is, remember when we were discussing about the Bitcoin, how the transactions and how the coins and the monetary values have been arranged, right? First of all, we had immutable coins, in case of Bitcoin, and it's a transaction-based ledger. So that means we only go one step backwards to verify the transaction, and there is no account-based kind of thing. So the money is the balance is in the form of different transactions, right? So basically, even if you hold a few Bitcoins, it will be nothing but a collection of unspent transactions, right? So that's how the structure of the Bitcoin maintains the value. But in case of Ethereum, as we also discussed about when we're discussing about smart contracts, when we want to write smart contracts and things like that, more account-based ledgers are quite comfortable, because account-based ledgers, they can maintain the balances like similar to our bank accounts and things like that. So that's why account-based ledgers are more suitable for the smart contracting based languages and things like that. So Ethereum also keep track of the balances. So not unlike the unspent transactions in case of Bitcoin. And they use a different structure. It's called Merkle-Patricia ties. Ties is nothing but you have 3 nodes. So similar to the Merkle tree, you have 2 hash nodes. So the transaction hashed and put into these nodes like that. But on the other hand, you also have an additional node which is used to extend the tree further, and which actually helps to validate the existence and non-existence of the transaction in a very, very fast pace. So that's why they adapted the structure. Merkle-Patricia ties, 3 branches compared to the 2 branches in the Merkle tree in case of Bitcoin. Again, they moved to the proof of stake protocol with the Castor protocol. So that's what and what does the Ethereum nodes do? So they collect all the transactions, they validate the transactions, and they create new blocks similar to like what we have seen in the Bitcoin. So the miners collect the transactions, and there we had this unspent transaction pool, right? So a collection of unspent transactions, and the miners will take the transactions from the unspent transaction pool and validate and put them into the block. Here also, they collect all the transactions which need to be verified, and then they also pack them into the blocks using Merkle-Patricia structure, and then it goes in the similar fashion. And they operate in the peer-to-peer fashion, and each node contains a copy of the entire blockchain. And you can also have the light claims. So that means if the node is not validating and creating a block and things like that, then it doesn't need to have all the blockchain, entire blockchain. So these are called light claims. So what they do is they only store the block headers, similar to even in the Bitcoin. You can also have a light claim which only maintains the headers, and they download the import. They don't download the whole blockchain. They only download the blocks which are needed for verification of a transaction and things like that. Right. So similar to that, you also have the light nodes, light clients here, which actually only store the block headers, and so that the basic purpose is to see the easy verification through the tree structure, and then they want to see that the transactions, and especially for the balance verification, right? So for example, what is the balance of the account which is linked to the smart contracts and things like that. So when it comes to the accounts, there are 2 types of accounts and wallets we use in Ethereum. So one is the externally owned accounts. These are like a normal, you can say private accounts, right? So basically, let's say that you have some ethers, you bought some ethers, and the way you maintain is you keep the ethers in your account, right? So similar to a bank accounts and things like that. And then the smart contracts will also have the accounts. So that means when we deploy a smart contract, and then you can also transfer ether to the smart contract account. For example, if the smart contract needs to transfer the ethers to some other account and things like that, so you have these 2 types of accounts in the Ethereum. So private owned or externally owned accounts, this is the most common account. And you have the contracting account, which is linked to a smart contract. And similar to the Bitcoin, it also contains public private key pair. So, and then allows for interaction with the blockchain using the same stuff it will apply. So you have the address. Most of the times you can use address as the public key, and then private key is used for authorizing the transaction, right? So spending the transactions and things like that. And you also listen many times the wallets. So what is a wallet? Wallet is nothing but it contains one or more external accounts, right? So it's you can say a bit higher than the accounts. So for example, let's say that you have Ether at several accounts. Then what you can do is you can combine them in one wallet, and the wallet keeps track of the balances and things like that. So it's a wallet is a software. Let me put it like this: it's a software which communicates with the blockchain, and then send the transaction on behalf of you, and all other things. It will does the functionality. And again, it will be used to store and transfer Ether. So like any kind of normal account for storing the money, right? So and then you can have so how these two accounts differ, right? So on one hand, you have the externally owned accounts. Let's look into this one, right? So let's say that I have my account, and then I need to transfer one Ether to one of my friend. Then what I do is I will send the Ether. I will transfer the Ether from here, from my account to my friend's account using a transaction, right? So this is just like the same as what you do in the normal banking, right? So of course, in case of normal banking, you have a bank as an intermediary. So you transfer to the bank and things like that. Here, what you do is you have your own account, and then you create a transaction to transfer the money in the form of ethers to another account, right? So this is normal typical thing. But on the other hand, you can also have a externally owned account, which can call a smart contract. So, for example, let's say that I want to buy some stuff, right? As we have seen in the supply chain and example and things like that, the smart contracts will be deployed. Let's say that I want to buy some stuff, then I will invoke the smart contract by creating a transaction. And for example, if I'm purchasing a book, then I will transfer that much amount of the money, you provide your wallet information and the balances and all other things, and smart contract it can create. You can invoke the smart contract using a transaction, right? You can also have the communication between the contract account to contract account. What does it mean? So let's say that you have one smart contract. It can also call the another smart contract. It's like the web services, right? You can have web services which can be consumed by the applications, or you can also have the web services, one web service calling the other web service. So similar to that, you also have the smart contract calling in another smart contract also. And then you can also have some kind of transaction generated and things like that. So if you look into a Ethereum blockchain from a high level perspective, basically blocks contains the transactions which are invoked by different accounts, right? So basically you have accounts, and then you create transactions, making transfers between the accounts or calling it to a smart contract and things like that. And all these things are part of the blockchain where all the transactions have been put. Remember, we discussed about the life cycle of a smart contract, and at each stage the transactions will be put. Sometimes the transactions carry some transfers, monetary transactions and things like that. Sometimes they also store information and things like that. So let's look a bit deep into the accounts and wallets. So external accounts, so they have a valid Ethereum addresses, and they have a nonce account of the transaction sent from that account. So basically, and the balance. So how much money you have in the associated with the account. Then you have a code hash. What is code hash? Remember, we were discussing that the accounts could be two types. One is the normal account, which has a balance of money and things like that. The other one is a smart contract, right? We discussed that the smart contracts can also have the accounts. So this is code hash is nothing but the hash of the associated account code. So that means this is the hash value of the smart contract code. And in case of external account, they don't have any code, right? So then you just put a hash value of a empty string for the external account, right? So, and then you have a storage root, which is root hash value of the Merkle Patricia type. So this is nothing but a cryptographic structure associated with all the account data. So for example, let's say that you have a series of transactions made from your account, and all that information will be organized into this form and things like that. And remember, this is the same form structure which is also used with the blocks for arranging the transactions. So here is the some more information about accounts. So you have nouns and you have the balance, in terms of the value of the coins or ethers or whatever it may be, and then you have the code hash if there is a code associated with it. And in case of external account, it will be nothing but we just use a empty string to create that one and storage root. In case of contract accounts, you have the code, which is written in some language. Most of the times it is Solidity, but people can also use other languages to write, to develop the smart contracts, and then they compile the code using the proper compiler, and then you have the smart contract compile code, right? So the compile code is, and the hash value of the code is put into the smart contract. Apart from that, there is not much difference between the normal accounts, or you can say externally owned accounts, and the contract smart contract. Okay, so let's look into transactions. So what is a transaction? A request to modify the state of the blockchain. Again, one more important thing is Ethereum is like built on the state-based models. So that means the idea is that you travel from one state to other state by invoking some state changes and things like that. So when you add a transaction to the blockchain, it is like modifying the state, and it is moving to the next stage and things like that. So a request to modify the state of the blockchain, the transactions are the main pieces of actions which actually invoke state transitions in the underlying model. So can run code like the contracts which are written in the suitable languages, and then contracts only the balances updates with the Bitcoin. So Bitcoin has transaction based balances, but here we have account based balance, and the signed by the original account. So basically, similarly following the same pattern, because we have the private and public keys here, and so when you create a transaction, the private key will be used to sign the transaction of the account from whom the ether or the coins are being transferred, right? And then there are different types of transactions. So one simple transaction could be like sending value from one account to other account, right? So for example, if I'm transferring money from my account to my friend account, this is one kind of plain simple transaction. Or creating a transaction, the smart contract is a transaction. You create a smart contract, deploy it, and all other kinds of things. And one more thing is execute smart contract. So let's say that you have a smart contract which you want to consume, and you invoke the smart contract, that will also become a transaction. As we have seen in the life cycle of a smart contract, where information, or you can say in the form of transactions, is put onto the blockchain. And Ether, we have different denominations of the Ether. So basically, one Ether is split into smaller parts, because you also need to pay the transaction fee for the transactions, right? So you need to pay a fee for the transactions. Otherwise, they will not be included into the blockchain, underlying blockchain, and things like that. So normally what we do is we split Ether into the lowest denomination, so which is called V. And so V Dai, the author of the V Money, and we discussed this in the last course when we look into the evolution of the Bitcoin, right? So, and then yeah, you have some other denominations. Basically, you pay the transaction fee in the terms of GV. So it's a gigabyte of V. We'll come back to that a bit later. So a bit about smart contracts. So the executable code, and unlike the Bitcoin, and when we were discussing about the scripting in the Bitcoin, right? So Bitcoin has the Bitcoin scripting language, right? So we discussed that it's not a Turing complete language, right? Because it doesn't offer loops and other kinds of things. So there are some constructs which prevent from Bitcoin scripting language becoming a Turing complete. Unlike that, the Ethereum smart contract language is Turing complete. So that means you can also encode advanced functionality. So normally Turing complete is a test which we use for testing the programming languages. So this is a Turing complete language. And yeah, smart contracts function like the external account hold funds and can interact with the other accounts and other smart contracts. So like send money to the accounts, transfer money to the accounts, or invoke the smart contracts from the smart contracts from the other contracts and things like that. They contain code, and they can be, the way to invoke them is through the transaction, right? So how does the code execution happens? Every node contains a virtual machine similar to Java. So in case of Java, we have the Java virtual machine, which contains the bytecode and things like that, right? So similar to that, even the smart contracts in Ethereum, you develop them, you compile them, and then you execute them using the Ethereum virtual machine. EVM is the environment which actually uses code execution. Compile the code from the high-level languages to bytecode. So you can use different languages, and then you can compile it to the bytecode, right? So, and it executes the smart contracts and then broadcasts the state. So every full node on the blockchain process every transaction and store the entire state. So that means all the smart contract information is also available with the nodes. The full nodes contain all the information they download, and they keep it updated. So let's look into some of the gas. So unlike the transaction fees and the block rewards in the Bitcoin, we use gas in Ethereum, right? So there are few purposes for using gas in the Ethereum. So first of all, halting problem. So what does it mean? So you don't want, because as we have seen, when you compare with Bitcoin, Bitcoin doesn't allow, Bitcoin scripting doesn't allow loops. So that's why you don't have big problems. But on the other hand, Ethereum is a Turing complete language. So that means you can use loops. For example, if you put an infinite loop, and if you send the transaction to the if you send the transaction, which could, when people execute the contract or the contract, then it can go on infinite loop, right? So this is the biggest problem for them. So that's why they don't want to, because what happens if you have an infinite loop, you keep on consuming the resources, so it will never come out, and it will waste all the resources by the miners and by executing the transactions in the code. Again, remember the transaction could be in the compiled form, and then so it's a really it can be a challenging problem. So cannot tell whether or not a program will run infinitely from the compiled code. So that is the biggest challenge, right? So if you have a smart contract, you compile it, and then you will only have the compiled code and things like that, right? So the solution it adapted is that it charges P per computational step to limit the infinite loops. So that means if you send a code, we will also look a bit detailed later, in a few slides, where I use an example to how the transaction look like, the transaction fees and things like that. So if you let us say that you have infinite loop in one of the transactions, right? Or you can say one of the smart contract code, right? And then you want to execute this, invoke the smart contract, and then you want to execute it, right? You need to specify how much gas you are going to pay, and the gas is consumed for each computation step. So that means, let's say that you specified some gas which is not sufficient to execute it completely. Then what happens? You will lose the fee paid as gas for you, and maybe if you are transferring money through that one, then you will get back your money, the money which you are trying to transfer to someone. But on the other hand, the processing fee paid as a gas will not be returned to you. So that's why to avoid this problem of infinite loops, and also to fight against people trying to hack the network by using this infinite loop and malicious code and other kinds of things. So they resolve to paying fee for each completion step. So every transaction need to specify an estimate of the amount of gas it will spend. So when you send a transaction, you need to specify that how much gas you are going to spend. And then at a later point of seeing what happens if it is more or less than what is needed in the transaction and things like that. So essentially a measure of how much one is willing to spend on the transaction, and even if it is lucky, right? So that is the gas transaction things. But before going into gas a bit more, the gas semantics a bit more, let us look into the kind of proof of work versus proof of stake happened in the Ethereum, right? So Ethereum moved to proof of stake in 2022. And so on one good thing is, it has really improved the energy consumption a lot. So you can see that they reduced the energy wastage by 99.5%, 95%. So it really brought down the energy consumption. So now it is more accessible to deploying many transactions and things like that. And another thing is, previously the miners, the nodes, you can say, nodes used to mine using the proof of work. Now they became the validators, right? Because now you have a proof of stake, and what you do is you deposit some money, some value into the escrow account, and then you do this proof of stake validation, or you can say you do this block validation, and making a block and putting network and things like that. So the more escrow you post, the higher probability that you will be chosen to nominate your block. So this is like some kind of auction, or you can say not exactly auction. It's kind of because there will be, depends upon the consensus protocol, there will be some kind of randomization to choose who will be selected to make a next block and things like that. And remember one thing, if you nominate a block with invalid transactions, and then you will lose your escrow account. So all the deposit the miner has put into the as a escrow. So escrow means some kind of guarantee, right? So as a guarantee, that will be lost. So that's why nodes, they don't try to put invalid transactions, because they will end up losing money, and maybe they will not be, their blocks will not be picked up and things like that. But on the other hand, moving to proof of stake, it also created a bit of centralization, right? One issue with this approach is that so those who have the most of the stake in Ethereum, and they will able to get more and more chances to make a block and things like that, right? So this is like, again, leading to some sort of decentralization eventually. And on the other hand, it reduces the chance of 51% attacks. Remember what is 51% attack in the Bitcoin? So that means if you can get hold of the 51% of the network resources used for mining, and then you can literally create blocks, invalid blocks, and you can hijack the network, right? So that is called the goldfish attack and things like that. So which is also called the 51% attack. But now we have the proof of stake. So that means we have some kind of guarantee in the escrow account, and we know who is doing what and stuff like that. It will eliminate the chance of 51% attack and things like that. And again, this escrow account is also in a way to make them behave in a nice manner and things like that. And the protocol is the Casper protocol. So remember, we have discussed several protocols on the proof of stake. So they use this Casper protocol, which is a variant. We'll see more later. So what kind of languages you can use? Solidity is the most used language, and you can also use Serpent. It's like some kind of low-level language and things like that. And Lisp, you can use it, and Mutant. So basically, you can use whatever the language develop, and Go, you can use Go and JavaScript and other languages also. So basically, you compile them, and then it will become a bytecode, and then which could be executed by EVM, right? Virtual machine, and then it will run. So Ethereum compilers compilate smart contracts written by different languages into the machine code, and then it will be loaded into the EVM and run. The EVM is also, it understands how to run, execute these step-by-step instructions in the smart contract, and then it will be executed. Okay, so let's look into some of the main key takeaways in the Ethereum case, right? So how does this, because this is also important to understand, when we develop the smart contract, we need to pay for the gas. What is gas? Gas is nothing but some kind of estimation of a computational unit of work it need to be done. So the gas is an important thing to make the transaction value, right? So gas refers to the unit of measurement, the amount of computational effort required to execute the specific operation on the Ethereum network. Remember, we have the network, and the miners need to spend some resources in terms of money or whatever the thing, power and other kinds of things, to validate the transactions, and to make sure the transactions are valid, and put them into the block and make the blocks, and again compete with the others and things like that, right? So since each Ethereum transaction requires computational resources to execute, so those resources have to be paid to ensure the Ethereum is not vulnerable to spam and can get stuck with the infinite loop and other kinds of things. So that's why we have this gas, right? So payment for computation is made in the form of the gas fee, and the gas fee is nothing but the amount used to do some operation and multiplied by the cost of cost of the gas in terms of ether, right? The fee is paid. One more important thing is the fee is paid regardless of whether the transaction is succeeded or failed, right? So that is one important thing. And this is the execution flow of a transaction and things like that. So transaction, it contains a series of instructions, right? And you specify the amount of gas you will be willing to spend for this transaction, right? And then what happens is you have this the transaction code or EVM code and things like that. So it is nothing but a step-by-step operation, a stack-based instructions. So each instruction will be read and it will be executed. For example, let's say that instruction is to message a external call, call an external entity or external URI or something like that, and then some gas will be spent. It requires some gas. Similarly, it for all the other kinds of steps as well. For example, writing to memory or reading from the memory and things like that. And the stack will contain the sequence of instructions and things like that. So the gas will be consumed for each and every step. If the gas available is sufficient to run the full transaction, full code, full instructions in the code, then the transaction will be successful. And then a successful transaction message will be written, right? Let us say that if the gas is not sufficient to run all the steps in the code, right? So let's say that the gas is not completely sufficient, and maybe let us say that the transaction was only halted in the maybe 60% or 70% execution of the instructions, right? Then what happens? The transaction will return a failure. So if any resources associated with it, I'm not talking about the fees. For example, let's say that I'm transferring 1 ether to my friend, right? And then that the money will be returned back because now the transaction has failed, right? But whatever the gas, whatever the transaction fees paid as part of the gas and ether, so that will be lost because they are burnt or spent in executing this transaction, right? So even if the transaction is a failure, you don't get your transaction fee back. So that's also a good thing. So that will demotivate people to attack and put infinite loops and things like that. If you try to put an infinite loop, or if you put a buggy code which will make the transaction fail or create some problems, then basically what you are doing is you are losing your gas unnecessarily and things like that. So okay, so let's how the gas fees work. So gas fees must be paid in the Ethereum. So the native currency is Ether, and so gas prices are normally quoted using GV. So that is a denomination of Ether, and then it is nothing but 1 billionth of Ether. So very small amount of Ether and things like that. And you can also set the amount of gas you are willing to pay for a transaction when you submit. So that means you will say that, okay, this is my maximum amount of gas I can pay at the most for this transaction, and that will guarantee that the miners might look into the transaction, how much you are paid, and then they will execute them. And then if the transaction consumes less amount of money, that will be returned to you back, right? So one important issue we have to remember is if you offer too little, let's say that you put too little transaction fee, and then it will your transaction, the chance that your transaction will not be included in the block is more. So that means it will not be attractive to the miners, because you can see that the fee is too little. So that means the amount of tip or the priority fee which they receive is less. So that's why it will they might choose to ignore your transaction and maybe go choose a transaction which is more profitable to them, or we can say which has much more tips, or you can say which has much more priority fee. So those transactions will be picked up and put into the block. On the other hand, if you offer too much, or you can say if you offer too much transaction fee, yeah, definitely your transaction will be picked up by the miners and it will be put into the block. But on the other hand, you are losing money, right? You are losing, you are wasting your resources, right? So you are wasting your ethers and things like that. So that's why, again, when we are discussing about the challenges of the smart contracts, we discussed that many smart contracts have you can say um, expensive patterns. So that means they of course that boils down to the programming structure and the maybe they are not optimized for the gas and things like that. So they ended up spending more gas than it is and things like that. But here in the case is, so you have to know what is the appropriate the fee which you want to use it to get your transaction into the block and things like that. Of course, the wallets will help you on that, but let's look into more into these things, right? So if you look into the transaction fee, or you can say the gas fee, it contains two parts. One is the base fee, and the other one is the priority fee. So the base fee is nothing but it is set by the protocol. Remember, we were discussing about hash difficulty in terms of the Bitcoin, right? We were discussing that the hash difficulty, that is the number of zeros preceding zeros you need to have in the hash in the hash value of the block header, is decided once in every 2 weeks, right? So similar to that, in Ethereum also, there is a mechanism which actually calculates the base fee. So base fee is nothing but it is calculated by the protocol. So this will tell about you need to pay at least this much amount for your transaction to be considered as valid. So this is like the bare minimum fee for the computation unit and things like that. And then you have this priority fee. What is priority fee? Priority fee is nothing but a tip you leave in the transaction, so that you want to make your transaction much more attractive to the miners, so that they can pick it up and they can give some priority to your transaction and put it to the block, right? Execute the transaction and things like that. Basically, to make it attractive to the validator, so that they can choose your transaction, put it to the next block. So a transaction that only pays the base fee is also a valid transaction technically, but on the other hand, it is unlikely to be included in the block. So for example, you only provide the base fee and you don't have any kind of priority fee or tips or something like that. And then the transactions will be, of course, valid. They cannot reject it and things like that. But on the other hand, it might not be picked up by the miners and made it to the block or something like that. So it might be laying here like that, or delayed transactions and things like that. Right? So the correct priority fee is determined by the network usage at the time you send the transaction. So basically, it also depends upon what is the base fee you have it. That is decided by the previous number. That is decided by the how much the gas is consumed in the previous blocks, right? And the priority fee is decided by what is the network demand and usage at that point of time. So that means, so normally the wallets will handle all this information, saying that they will suggest you maybe you can pay this much is the fee which you can pay to get your transaction executed or something like that. Okay, so this is an example of the transaction fee, right? So for example, let's say that Jordan has to pay Taylor 1 Ether, then a Ether transfer requires 21,000 units of gas. So this is nothing but the computational units. You can say that gas is representing the computational work to be done, right? So it's a very small unit, so that's why let's call it as 21,000 units of gas. And let us say that the gas price is 10 GV. So that means that is the current price of the gas and things like that, the market price of the gas. And then let's imagine that Jordan want to include 2 GeV as a priority fee, right? So as a tip. So now the total transaction is, since you need to consume 21,000 units of gas, and then you multiply with the gas fee, so which contains the base fee, which is 10 GV, and the priority fee, we want to leave 2 GV as tip. So it will be 10 plus 2, 12 GV. So which will be like 250,000, 52,000 GV, right? So this is nothing but 0.000252 Ether, equivalent to that. Okay, when we send this transaction, now we are transferring money from one account to other account, right? So we want to transfer 1 Ether. And then what we do is we add 1 Ether and we add this transaction fee. So it will become 1.000252 Ether. And we will use this, transfer this as part of the transaction execution, right? So then the validators will execute the transaction, and when they execute the transaction, they will receive a tip of 0.00042 Ether. Remember, this is the priority fee, right? So the priority fee is 2 GY, so which will be like 42,000 GV, which will be like 0.00042 Ether, right? So this is the priority fee, which will be collected by the miner who executed this transaction. And the base fee, we have the base fee. The base fee will be burnt as part of the execution transaction. So that means whatever the base fees we specify, that will be burnt and removed from the network. So that's the important thing. So only the tips will be collected by the miners, and the miner, if his block made into the chain, and then he will receive the reward. For example, 5 Ethers he will receive. On top of that, he will also receive this tip from this transaction. Similarly, he will collect all the tips from the other transactions, and he can transfer to that one. Right? And then there was an interesting mechanism in the Ethereum to maintain the base price. So the base price, as I mentioned before, the base price is decided by the previous blocks, right? So how does it work? So Ethereum specifies that each block has a target of 15 million gas. So that is the size of the block which they specify. And but the size of the block can increase or decrease in accordance with the network demand. Let's imagine that there is huge demand in the network. So there are many transactions are put into the network and executed at the same time. Then people can put more transaction to the block, and the block size can exceed than the target size of 15 million gas, right? So for example, let's say that this is the target 15 million gas, and if it is 15 million gas, 15 million gas size, no increase in the base price. So let's imagine that we have 100 GV as the base price, and we will have the same thing. let's say that due to the increase in the demand, of course, the blocks can go up to twice as the target size. So that means they can pack transactions up to 13 million gas. Right? So then the second block is now with 13 million, right? So it is exceeding the target block. And then what happens is for the next block, the base fee will increase by 12%, 12.5%. So that means previously it is 100 EV and now it is 112.5 GV you need to pay for each base transaction. And let's imagine that still the network is fully loaded. So you need to increase this 12.5% increase in each block you create, right? So this is like nothing but an exponential growth you can see here, right? So if we keep on having the blocks with the heavy blocks, for example, 30 million gas and things like that, then you will be ending up increasing the base fees. So that means then you can see that now the customers, the people who want to create transactions, they have to pay more gas fee. Probably if the transactions are not important, they might wait a bit little so that the gas fee can be reduced, right? But on the other hand, let's say that we have at the 30 million and then the network load has dropped, and then you can decrease the base fee. So that means it's not only increasing, but you can also decrease the base fee. So whenever it goes below the 15, and then the fee will be slashed down and things like that. So this is a mechanism which is used to maintain the fee structure, or you can say the maintain the demand in the network and things like that, which is very much similar to the hash difficulty mechanism in the Bitcoin. Right. In case of Bitcoin, we use hash difficulty. If the blocks are being produced at a faster pace than the 10 minutes interval, then what we do is we increase the hash difficulty, which is converted into the number of zeros you need to have in the hash value, and that means now the miners need to do more work. It will delay them in creating the new blocks and things like that, right? So more work need to be done, and so more trials have to be made for solving the hash puzzle and things like that. Similar to this, but here we have another mechanism which is trying to limit the block size in terms of the gas. So if you have more blocks, heavier blocks, then you ended up paying the increasing the base fee, which will discourage the people who put the transaction. Now they need to pay more money, right? So that is the main criteria. And yeah, first of all, why do gas fee exist? As I mentioned before, gas fee is a kind of protection against the attacks on the Ethereum, right? So, and as we also discussed previously, this is also a protection against the malicious behavior. For example, purposefully not putting the infinite loops and create a wasting the resource and things like that. So this is like a quite important step in finding against the protection for the Ethereum, right? So you can explicitly state how much gas you are willing to pay to get a transaction. So that's the max gas. Our most wallet provides this estimate automatically, right? So they will tell you what is the base fee. Base fee is derived from the network. So it is calculated based on the previous blocks. So you will know that what is the base fee, similar to this, and that is decided. And then the wallets will also help you to find out what is the approximate tip you need to provide. And based on your transaction urgency, you might want to, let's say that you want your transaction to be executed immediately, right? So you are in a bit hurry, and you want your transaction to be immediately ended up in a block. So then you will go for a higher fee than what is recommended by the wallets. You put more tip, And otherwise, if it is not very critical, then you go by whatever the wallet has suggested, and then your transaction will be eventually executed and put into the network and things like that. So, and again, this is mainly to accidentally or hostile infinite loops, or to with a plan to separate the network and things like that. So that they don't waste the computation, they don't wastage the resource. Again, why this is happening in Ethereum and why is not in Bitcoin? Bitcoin scripting doesn't allow any kind of loops. So if you have no loops in the scripting language, then there is no way of you creating an infinite loop, right? But since Ethereum is a Turing complete language, and it allows for loops and other kinds of advanced structures, right? Then you have a possibility to get all these malicious attacks, or you can say poisoning attacks, to poison the network and waste the resources from the network and things like that. So to fight against them, then you have this gas mechanism, right? So how does this gas mechanism works? So you say that you will specify the max fee. So for the you are willing to pay for the transaction and things like that. Let's say you have a transaction, right? And then the transaction will be executed, and so you have some gas associated with it, and you supplied the gas along with the transaction in the form of ether, like what we have seen before, right? So then you have the some sort of available gas supply. You will try to execute the code, and each iteration, let's say that if you have a loop, each iteration will consume some gas, and whenever the gas supplied is insufficient, then the transaction will be aborted, and it will return a failure status, right? And on the other hand, let's say that the code is right and valid, and it is executing something correctly. Then what you do is you specify the max gas. You specify the how much amount of max gas you want to spend and things like that. The transaction is executed according to the steps, and if the fee is left over, then it is also returned to the user, something like that. So yeah, what is the gas limit? So this is the gas limit is nothing but the maximum amount of gas you are willing to consume. And how do you calculate this? Basically, based on the number of operations your smart contract will do, right? So this is a very simple calculation. You look into the total number of operations. Basically, what we have seen here, right? So in this example, we have one single operation. Let me go back. Yeah. In this example, we have one simple operation, and which consumes 21,000 units of gas. So if you have a smart contract, and you will calculate all the number of operations needed based on the logic you are in the you deployed in the contract, and all this will be calculated, and then you will specify the maximum gas limit like that, right? So yeah, that is the maximum gas limit you can specify. More complex transactions involve more and more operations. So then um, you need to put more amount based on the complexity of the transactions and things like that. So for example, if you put a gas limit of 50,000 for a simple transaction, let's take this simple transaction, right? We have this transfer cost 21,000 units of gas. Let's imagine that this will take 21,000 units of gas, right? If you specify the maximum max limit to 50,000, then the EVM would consume the 21,000 because it only contains one transaction. And so it will consume 21,000, and it will return the 29,000 back to it, right? So just let me check. There is okay, so I did not understand. Okay, maybe can you write a bit more details or speak about it? Is it the gas limit which you don't understand? Sorry, I'm looking into the chat. There is a message saying that I did not understand.
Yes, Swastik, can you be clear with what you want the professor to repeat? Swastik, are you there? Okay. Oh,
Yeah,
yeah.
like every time gas limit. Yeah, the gas limit normally, when you, let's say that you have a spot contract, right? So if you, because this comes from the point of view of course, you will calculate the number of operations and things like that. But on the other hand, if it is a compiled code, there is no way of the miner knowing how many operations it will consume, right? So until unless you execute this step by step, you don't know it, right? So what you do is you will have some kind of calculation. On one hand, you put the ether and other kinds of things. Yeah, you calculate the base fee, you calculate the priority fee and things like that. You put calculate that amount and then you transfer along with this transaction. On the other hand, you will also put the maximum gas limit. So that means, yeah, for example, let's say that your transaction takes more number of steps, then that is the point it will stop, right? So, for example, let's say that again, let's take this simple case, right? You specified that the maximum gas limit is 50,000, right? Let's imagine that you have a bug in your transaction in the code. So it consumes more than the 50,000. Then what the miner will do is at the end of the 50,000, he will start executing your transaction because it is consuming more and more. And then it will simply return failure status and things like that. So the max limit is a way of approximately indicating how much you are putting as gas limit and things like that. So it's like a kind of safety mechanism to not to exceed that one, right? So if you know that your transaction is going to cost maybe 20, 30,000 gas units, then you will say that, okay, a higher figure or something like that, just to be sure that it might take a bit more because it's the real world, real-time execution engine and things like that. So just like a security marker which we have. So yeah. However, what happens if you, let's say that you have 20,000, let's say that we have one operation, very simple case, like what we have seen in the example, right? So which consumes 21,000 gas. Let's imagine that. And now we have specified too little gas, right? So for example, I put a gas limit of 20,000. And then by looking at this one, the while executing the transaction, since this limit has reached, then it will stop executing the transaction and the transaction will not go further, right? So it will return a failure state, or you can say um, aborting the transaction. And what will happen? Let's imagine this case where we are trying to transfer one ether to the another person. Then the transaction failed because it doesn't have the sufficient gas. And then the one ether will be returned back to the account. And whatever the gas fee you paid, whatever the transaction fee you paid in terms of the gas, that is consumed and that is lost, right? So you will only get your money, but the transaction fees will not be returned because they are already, at least the base fee is already spent, right? So yeah, the EVM then reverts any changes, but since the validator already spent done 20,000 gas units of work, because he executed the transaction to that point, right? So that is then the gas is consumed and it will not be returned. So yeah, and this is nothing but the units of ether. So ether is this is ether, right? The transaction fees are very, very less, right? So normally you will measure the transaction fees in terms of giga V. So I think the current transaction base fee is like 40 gigaV or something like that, right? So that is the price of the gas now. And yeah, so these are some big units to measure ether and some small units to pay the transaction fees and the base fees and the things like that. Yeah, this is an example of the smart contract code. Again, we'll go back to, we'll look into more when we go through this programming, right? So Solidity programming and things like that. So yeah, any questions or comments? Anything you don't understand or something like that?
Yes, sir. A student Bhargav Singh have asked a question in the chat. How can
Yeah.
we calculate the gas limit?
The gas limit, normally you will basically you will sum up all the operations, tentative operations and things like that, and then you will because you might your calculation might be might contain a big mistake or something like that. So that's why it is basically summation of all the kind of operations the contract will take, right? So, and many times the developing environment depends upon which developing environment you use. It will give you approximate estimate, right? So you don't need to calculate manually. So it will give you, and then based on that you can specify just for in case something's ignored or something like that, right? For a case of simple smart contracts, this is not a big issue, right? So, but when you have the smart contracts with the complex code, you might have hundreds of lines of code, and then there are different paths you can have, like then different execution states. So all these things will complicate in the calculation of the how much gas is needed and things like that. But normally the IDEs will help you to give a rough estimate. So that's why you will have a bit more as max limit or something. But we'll get into those calculations when we do the programming using Solidity. Okay, so any other questions or comments? What's your take on the networks like Algo RAM that are trying to allow developers to interact with the network in Python? Okay, so I have no idea on that, but I can look into it more detail and come back to you next week, right? So yeah, honestly, I don't know the answer. So yeah, but Python kind of languages you can use. Even Ethereum, there is a language, I forgot the name, which is similar to Python based syntax and things like that. So, but I have no idea about this Algo flag. I will check about that and come back to you in the next week. Okay, so any other questions or comments? I will take, yeah. We have to pay gas limit on NFTs. Yes, NFTs you need to pay. You need to definitely you need to pay, and you pay. I think I read something about NFTs. NFTs, yeah, you have to deposit the transaction, and yeah. So, but I will get back to even in NFTs next time. Every time or once? No. NFT, when you create a NFT, it's like a creating some kind of footprint, right? Or you can digital footprint or digital token or something like that. So you will only pay it when you create the token. But for validating the token, you don't need to pay. But if you, let's say that you create an NFT for art or something like that, right? So then definitely you will pay at the time of creation. Depends upon the amount of gas it requires and stuff like that. So you will definitely pay for creating the NFT. But when you transfer the NFT, let's say that you sell this NFT to put it in the auction and sell it, right? And when you sell it, it's nothing but the transaction cost. You don't need to pay anything on the NFT. So that's my opinion. but I'm not 100% sure on that, but I can check it and come back next.
Yes, sir. I think during when an NFT is minted, then the person who is minting pays the gas fees for that, and whoever is buying it from that auction would pay the gas fee just pay to make the transaction happen.
Yeah. So I even I think so. But yeah. So like you only pay for the execution of the transaction. So for example, in this case, if the NFC is transferred to someone, right, and then it's like like buying a house, right? So when you buy a house, the seller will sell house. And then the buyer will pay the registration charges and all other things, right? Like similar to that, when you buy a NFT, and the NFT will be transferred to your account, right? So your wallet and things like that, and then you will pay the transaction fee. So only transaction fee of that transaction, but not anything to this. So that's why NFTs, they have one-time fee. But I read something about NFTs and some kind of calculation, but I will remember to look into it and get back to you more on that. Okay, so any other questions or comments? I will note it down, these questions. And but if you don't have any, I think it's already a bit late in India. So have a good night, and then
Yeah.
see you next week. Good night. I
Thank
already
you, sir.
copied the
Good night.
slide. Copied the slides, and I will copy the recording soon after this. Good night.